Good afternoon, audience. Here will deliver a presentation with the title Laminar Rayleigh Benard Convection, closed square field with meshless radial basis function method. As for our research team, I am Irfan and my promoters, Dr. Eko Prasetya Budiana, and then Professor Dr. Engineering Samsul Hadi, then Professor Insinyur Agung Tri Wijayanta, PhD. So, natural convection in a rectangular cavity, which is of great interest to researchers because of the transport process in fluids, where the motion comes from the relationship between density difference and gravity, which is very common in engineering and environmental problems. This analysis is widely applied to building design, ventilation, airflow patterns in greenhouse, solar energy system, solar air heaters, cooling, and electronic equipment, desalination system, and the others. Most of the natural convection research in square cavities is currently classified in two groups. The first is differential heating of the heated enclosure, with the thermal boundary conditions are on left and right walls. The second is a cover which is heated from below and cooled from above, or better known Rayleigh Benard. There are some experimental and numerical studies on a rectangular box are heated from below. So this is a literature research. First, Yili in 2022 with title Numerical Simulation on Natural Convection and Temperature Distribution of Supercritical Water in Side Wall Heated Cavity. This paper discuss numerical simulation on the natural convection and temperature distribution of supercritical water, in which the left side of the cavity is heated. And then Ortatani in 2008 with title Numerical Simulation of Two-Dimensional Rayleigh Benard Convection in an Enclosure. This paper discusses of two-dimensional numerical simulation of natural convection in a cavity with heating from below and cooling from above in our fluid or Prandtl 0.71 with various RA number 10 square 4 until 10 square 6 values. This method is the finite volume method, momentum and energy discretization using the rate and like successive hour relaxation method. And then this is literature research to run in 2012 with the title Laminar Rayleigh Benard Convection of a stress fluid in a square enclosure. This paper discussed the two-dimensional steady-state simulation of natural laminar convection in a rectangular cavity with a horizontal wall which is heated differently with the lower wall at a higher temperature with RA values in the range 10 square 3 to 10 square 5. This method using a finite volume method, pressure and velocity discretization using the simple method. This is a radial basis function method. Theories about radial basis function method is a function value that depends on the distance from some center point, and then RBF can be easily implemented for reconstruction planes or surfaces using scatter data in 2D 3D or higher dimensional domains. Here's this RBF equation. Uh, Research purpose. In the present study, the meshless radial basis function method that we're carrying out to solve the velocity vorticity formulation of the Navier-Stokes equation by varying the sum nominal Rayleigh Benard from 10 square 4 until 10 square 6, and then numerical accuracy is compared with previous research. Here, Al-Tatani and then Turan. So, this is a research method. First, we specify a boundary condition. Appears on image a closed square field where the right and left side are adiabatics, and then the lower side is giving heat and upper side is giving cold. The next determining the set equation. There are four set equations: continuity equation, momentum equation, and directional, momentum actional, momentum equation in y directional, and then energy equation. So the next step is discretization governing equation, and then next step is setup process, and then simulation process and validation data. If yes, conclusion. If no, back to setup process, preparation, and repair of program code, and then simulation again until yes. After that, conclusion, and then finish. Okay, the next step is discretization governing equation. According to the flow chart research, the first to be discretized is continuity equation. And then discretization momentum equation in X directional, and then discretization momentum equation in double Y directional, and then the last discretization is energy equation. The next step is to create a program code on MATLAB software version R 2015A. The arrangement is program identify geometry, position coordinate of each node, parameter to determine the value, Prandtl, Rayleigh number, boundary condition, and setup parameter, uh, and then setup and last result consists of several figure codes. Uh, Next step, simulation process and data validation can be see the figure can be complete with nodal 151 multiple and 151 with each step 10,000 for RA10 square 4 until each step 25,000 for RA10 square 5. So this is all result presented in this section for RA10 square 4 until 10 square 6 can be solved on 151 multiple 151 nodes. This number of nodes differs in research on Tatani. The non-uniform green is 256 square nodes selected for computation. So, current and isothermal line associated with array 10 square 4 until 10 square 6 are presented in figure 3, 4, and 5. And then velocity vectors of each cavity various as follows are shown in figure 6. And then 7 solves with motion U and P distributed along L x directional and h y directional is increasingly nonlinear with increasing RA value. Is graph of horizontal velocity and vertical velocity. And then this is table 3 comparison of the coordinate position U max and V max. This is our Tatani and then present study. In this study, average Nusselt number obtained from the current numerical simulation for RA 10 square 4 until 10 square 6 at handle 0.71 for incompressible fluids compared to previous literature result in table 4. This is our Tatani. Then this is a two-round research. So this is a present study. That the current result are from the last numerical result. Conclusion. This meshless radial basis function method can solve numerical solution on Rayleigh influence array from 10 square 4 until 10 square 6 on thermal values. Simplified contours and the distribution of the speed of movement of fluid in the cavity have been investigated in detail, and the results show the same pattern and velocity graph as previous studies. So, acknowledgement, this research is supported by Universitas 11 Maret. This is a number green. So, thank you. If have any question or discussion, can send an email list. Thank you.